this light. Okay, let's start. I don't see any of the Algebra 2 peeps yet, so I'm a little bummed out because I did this. I changed last minute my lesson plans just for them. So hopefully they'll come in next group, who knows. Let's chat about the subject. Let's chat about trig ratios from geometry. So Chavez, what do you mean by trig ratios? So trig ratios only apply to right triangles, and I'm going to draw a right triangle right here. And I'm going to say this is how you identify that it's a right triangle. They put a little square on the little edge here. No matter what, the longest side is called the hypotenuse or the hypo. I just put hypo there, guys. Don't ever call it hypo, especially if you're talking to a professor. Just call it a hypotenuse. And then usually they put like alpha here and then beta. We're going to talk about that. Now, delta math is a common core state. So they love to use vertices. So I'm going to say A, B, and C for vertice A, vertice B, and vertice C. Now there's something called, there's an acronym. Oh, there's also a fancy educational word. I can't remember it. It's called SOHCAHTOA. SOHCAHTOA. Not suck a toe. That's just nasty, guys. And feet are just ew. Unfortunately, it's not like we can walk around with stumps, right? Because if we had stumps, then we'd probably be falling down and everything. So we're gonna have to deal with feet. But anyways, sorry guys, feet are just. So what does this stand for? The SOH, the S stands for sine. So I'm gonna say sine of some angle equals the O stands for opposite. So I'm gonna write OPP, and the H stands for hypotenuse. I'm just gonna write HYP, and that's it, guys. So the cosine, oh, by the way, I know that it's spelled S-I-N. Do not say sin. There are a few math jokes with Jesus Christ and all that, like, oh, you committed a sin, and they talk about right triangles. But it's pronounced sine, S-I-N-E. So whenever you see S-I-N with a theta on it, it's pronounced sine. And then cosine theta, C-O-S with a theta on it, that is adjacent over hypotenuse, and we'll talk about what adjacent means, guys. So how do you pronounce C-O-S? You pronounce it cosine. That's a C here, it just came out dumb. And then tangent. Tangent is T-A-N theta, and tangent is opposite over adjacent, because that's what the O and the A stand for. And you pronounce tangent, T-A-N-G-N-T, tangent. And there's actually a reason for why we pronounce these the way they are, but we're not going to get into that because that's another topic for another day. All right, so now next. So what does it mean to be adjacent? So I guess let's talk about A. I'm looking at A. So if I were to, well, I guess let's just go down the line, right? Sine, cosine, tangent, and then when we get to cosine, we'll talk about adjacent. So if I write sine of A, they're talking specifically about angle A. Angle A is identified with that alpha. So sine of A is, and I'm going to go ahead and put numbers here, guys. I'm going to say not to scale, NTS, not to scale. 3, 4, 5. This is a 3, 4, 5 triangle. Let me erase that hypo. Put it down here, hypotenuse. Okay, so here we go. Sine of A. What is opposite? So here's vertex A. What is opposite of angle A? 4. So I write 4. And then the hypotenuse, well, the hypotenuse is always the longest side, so you write 5, and there it is, and that really is it. That's it. It's just a ratio, something over something. If I write cosine, oh, by the way, if this is a common core thing, common core loves to use vertices, so they say A. I could have also said sine of alpha, because that's an angle. So sine of alpha is the same thing, guys, 4/5, and I'm gonna put those, and I'm gonna put same, because I identified the angle as alpha. So it doesn't matter, guys, which one you use. I'm going to stick with the vertice, guys. So that's the last time I'm going to say that. So here we go. Cosine of A. Cosine of A, it says here it's adjacent. Adjacent is just, well, you guys know, you guys are pretty bright. Adjacent just means take it to the next door room, right? So if you were to talk to your little brother or little sister and you give them a chocolate chip cookie and you say, little brother, I mean, I don't know, hopefully you're nice to your little brother, but little brother, take this cookie to the adjacent room. He's going to go, okay, and he's going to figure it out that adjacent means next door. So what's next door to this alpha here, or angle A? Well, what's next door is the 3 and the 5, but the 5 already has a name. The 5 has hypotenuse. That's what the name is. So it's always going to be the 3. So 3 over 5, and that's it. Cosine is adjacent over hypotenuse, and there it is. All right, tangent. Tangent of A or tangent of alpha. Tangent is opposite over adjacent. Opposite of that alpha is 4, so 4. And then adjacent or next door is 3, so 3. And there it is, guys. So let's talk about the C, the vertice C. We're going to do it again. So here we go. Sine C. Sine C, well, let's see. Sine is opposite of our hypotenuse. Opposite of this beta here, this angle is called beta, is 3, so 3. And then the hypotenuse is still 5, so 3/5. Next, let's do the cosine. And this time I'm going to use the Greek letter there. Cosine of beta. Cosine of beta, what's next door? It's adjacent of our hypotenuse. Next door is the 4, because the 5 already has a name. The 5 is the hypotenuse. What is tangent of beta or tangent of C? Tangent of C is opposite over adjacent, so 3 over 4. And there it is, guys, and it really is that simple. That's it. That's all there is to it. It's just trig ratios. All right, now there are other type of ratios. Why can't I say that word right? Ratios. All right, there are other types of ratios. They're called reciprocals. Reciprocal ratios. And don't worry, we're going to talk about them. So here we go. So the reciprocal of sine is called cosecant. And I'm going to write cosecant theta. So if I told you it's a reciprocal, that just means you look at sine, it was opposite of hypotenuse. So that means this has to be hypotenuse over opposite. And then it says C as C, so you pronounce it cosecant. That's how you pronounce it. So this next one here is called secant, S-E-C-A-N-T. And secant is the reciprocal of cosine, which means hypotenuse over adjacent. All right, and let me put a line here so we don't confuse ourselves. All right, the next one is called cotangent. So C-O-T, and you spell it out, cotangent. That's how you pronounce it. And it's a reciprocal of tangent, so it's adjacent over opposite. And that's it, guys. That really is it. So I'm going to use the top triangle here, guys, to do the same thing again. So I'm going to write CSC of A. If you want, you can look at the triangle, or you can just look at sine, because cosecant is reciprocal of sine. So the reciprocal of 4/5 is just 5/4. Or you could just say hypotenuse over opposite. Hypotenuse was 5, opposite was 4, and there it is. Secant of A. Secant of A, well, secant is hypotenuse over adjacent, so it's going to be 5 over 3. Cotangent of A. Well, instead of saying 4 over 3, opposite over adjacent, it's adjacent over opposite, so it's going to be 3 over 4. All right, let's do the C one. CSC of C. Cosecant of C. Well, cosecant is reciprocal of sine, so 5 over 3. And then I'm going to write secant of C. So secant of C is the reciprocal of cosine, and then 5 over 4. And then finally, cotangent of C is going to be 4 over 3. Now, in case you're wondering, you're probably there behind your computer saying, Chavez, how am I going to memorize all this? I can't do that. Like, yes, you can. And I'm going to show you. It's really simple. First of all, remember SOHCAHTOA, not SOHCAHTOA. That's, we already said, that's just nasty, guys. No. SOHCAHTOA. So remember SOHCAHTOA. So if you know SOHCAHTOA, you never have to remember anything, because you can just use your acronym there to figure out what's opposite, what's hypotenuse, what's adjacent, what's hypotenuse. Now, how are you going to figure out what's reciprocal of what? Well, notice cosecant is reciprocal of sine. This starts with a C, and sine starts with an S. So they toggle each other. Notice secant is reciprocal of cosine. Well, that starts with an S. Cosine starts with a C. So there it is. That's all you got to know. So that's the only brain teaser you need. It just starts with a different letter, an alternate letter besides the same one. So cosine, the reciprocal of cosine is secant. The reciprocal of sine is cosecant. And then cotangent, no one ever has any issues with cotangent because it literally sounds like, look, tangent is tangent, and then cotangent has to be the reciprocal of tangent. So no one has issues with the cotangent one. It's always a cosecant and secant that people get confused, but now you know the trick. Just look at the first letter. If we're talking about sine and we mention cosecant, oh, cosecant must be the reciprocal of sine. If we say secant, oh, secant must be reciprocal of cosine. And that's it. There's your little of how you know what is what. And there it is, guys. And it really is that simple. Don't worry, we're gonna do a whole bunch. All right, let's go to this one. Until you become super beast, keep writing SOHCAHTOA. SOHCAHTOA. So there it is, SOHCAHTOA. And then it's gonna say, find the exact value of tan A in simplest radical form. That means they want the square root in the top. So here's tan A, I'm gonna say here's angle A. So tan is this one, and tan means opposite over adjacent. So opposite, so let's see, tan A equals opposite, square root of 28, over adjacent. What's next door? Well, it can't be the 8 because that's hypotenuse, so it has to be the 6. Boom, you're done. But they want us to simplify. Let's see, because if you were to type this into Delta Math, I think it's going to count it wrong because this time it does want you, because it says simplest. So let's see, two numbers that multiply to give me 28. The biggest possible number is 7 and 4. 7 times 4. So the square root of 4, let's see, the square root of 4 is 2. So this becomes 2 square root of 7 over 6. Now before you leave it alone, don't leave it alone. This reduces. I see the 2 and the 6 there. 2 goes into 6 3 times. So finally, I'm going to write tan A equals square root of 7. And then we said the 2 goes into 6 3 times. So 3. And there it is. Oh, that's a nice smiley face. It's one of my better ones. And there it is, guys. It really is that simple there. All right, let's continue. Example 2. Find the exact value of sine A in simplest radical form. They're nice. They put all 3 sides. Oh, thank you. And we write SOHCAHTOA again until we're super beast. Once you're super beast, you no longer have to write SOHCAHTOA. And it says sine A, so I'm going to circle this one. So I'm going to write sine of angle A, and then I look for A, and then I put a little dash here so I know that I'm talking about that angle right there. So sine of A is opposite, square root of 63, over hypotenuse, 12. We can't leave it like that. 63 breaks down. Let's see, what times what is 63? I think that is 9 times 7. 9 times 7, yep. The square root of 9 is 3, so I'm going to rewrite sine A equals 3 square root of 7 over 12. And then just when we think that we're done, we're like, oh, we're almost done. Look at that 3 and look at that 12. 3 goes into 12 4 times. 3, 6, 9, 12. So finally, I'm going to say sine A is nothing more than square root of 7 over 4. And there it is, guys. See, it's not so bad. All this time, you guys were thinking that trig ratios were hard. Look, they're not even that bad. All right, let's keep going. In triangle XYZ, so here's XYZ, the measure of angle Z is 90 degrees. So they're telling me that I have a 90-degree triangle, which is perfect. That's what I need to use this trig ratios. XY is 39. Usually they have a line up here to say that it's a length, but either I forgot or that's how Delta Math had the format. I think that's how Delta Math had it. Excuse me. So those are my lengths, 80, 39, and 89. What ratio represents, and they spelled out the whole word, cotangent of angle X. So I go to angle X. So here's my angle X. So I'm going to write COT of X equals, and then cotangent is the, oh, I guess I should have written SOHCAHTOA, right? SOHCAHTOA. If you always want to reference your originals, that's fine. Tangent is opposite over adjacent, but this is a reciprocal. So it's going to be adjacent over opposite. So adjacent, I'm going to put theta. What's next door to my theta? The 80. What is opposite? The 39. If that 39 were 40, I could reduce it. But since it's 39, I don't think it reduces. I think that's it. You type that into your Delta Math, and it's going to give you a nice little check mark. Oh, that happy face came out kind of mischievous, or I can't say that word, but you know what I mean. Because it looks like, okay, I'll stop. Anyways, but yeah, so there it is. 80 over 39, it doesn't reduce, you're done. Let's go to the next one. In triangle GHI, the measure of angle I is 90 degrees. Perfect. That means I can use trig ratios. And then they tell you that IH is 12. That's a Common Core thing. They should probably be putting lines in the top, but that's fine. What ratio represents cosecant of angle G? So they went ahead and spelled out the whole word. Let's go ahead and write it correctly. Cosecant is CSC, and then I put the G in there. And then I guess what I said, right? I should have keep writing SOHCAHTOA until we're super beasts. Okay, so this is cosecant, which is the reciprocal of sine, the different letter that does not start with C. So sine would have been opposite over hypotenuse, so now I got to reverse it. Hypotenuse over opposite. So hypotenuse is 37. And then opposite, where's G? I didn't even, here's G. Opposite is 12. And you're done. That's it. Man, I should have put somewhere it's angle H instead of all these. Oh, well, too bad. We'll get some good ones right now. All right, I don't think it reduces. If that 37 were 36, we talk about reducing, but it's not, so we're good. And let's go to example 5. Now, when we draw our triangles, I put here, well, when I created the assignment on Delta Math last night, or this morning, when I created it, I excluded all quadrant 2, 3, and 4. So, you know, when I log in, you get options and you can choose what you want to, what type of questions you want to give them. And I just clicked on exclude quadrant 2, exclude quadrant 3, exclude quadrant 4. Not that I don't think you guys can handle it, because I think you guys can, but we're rookies and we just want to deal with everything that's positive, every positive number. So it says given sine A is 5 over square root of 89 and that angle A is in quadrant 1. Well, they're all going to be in quadrant 1, so that's fine. Find the exact value of cotangent A in simplest radical form using rational denominator. What that means is they don't want to see a radical in the denominator, guys. All right, so here we go. I'm going to draw quadrant 1, and here's my triangle, and here's angle A, or if you want to call this vertex A, so then that's angle A. So there's my angle A. I'm going to leave it like that. And it says sine is 5 over square root of 89. So I'm going to call this opposite 5, and this is square root of 89. How did I do that? SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse. So there it is, 5 square root of 89. They want me to give them the cotangent. So cotangent is the reciprocal of tangent, so I need adjacent over opposite. So I need this guy. I need to figure out what that length is. Since I have a right triangle, I can do Pythagorean Theorem. So real quick, guys, a side note, Pythagorean Theorem is just a squared plus b squared is equal to c squared, where the c is always, always, always hypo, the hypotenuse. Always your hypotenuse, your hippo. So now that I said that, what I'm trying to find is a leg here, and this is not drawn to scale, not to scale. So since I'm trying to find a leg, that's like trying to find either an A or a B. So it doesn't matter which one I isolate. If I were to try to find A, that would be c squared minus a squared, and then to get A by itself, you would take a square root, right? So A is equal to the square root of c squared minus a squared. So that's just a side note. And why did I tell you all that? Because I just like to go right into it. So if I want to figure out this length here, I just like to go square root, and I go square root of 89 squared minus 5 squared. Now, if you don't know, anytime you square a square root, that square root goes away. So let's see, I have square root of 89 minus 25, 5 squared is 25. And it looks like it's going to be perfect. Let's see, 89, 79, 69, and then that's another 5, 64. Yes, they're nice to me. So the math gods have been nice. And the square root of 64 is 8. So this length is 8. And there it is. Now I have everything I need, guys. So I'm going to write cotangent of A is equal to, well, let's see, tangent was opposite over adjacent, so it's equal to adjacent over opposite. So adjacent, 8. Over opposite, 5. Put a little happy face. Oh, that one looks a lot nicer. That one looks like your neighborhood kid saying, hey, you want to play? So yeah. Okay, here we go. Next one, guys. Or actually, this one reminds me of my nephew. Every time I go down to the valley, he's like, you got any games in your phone? So that's what that reminds me of. You got any games? Oh, that kid, man. All right, next one, example 6. Given cotangent A is 5/2 and that angle A is in quadrant 1, they're all going to be in quadrant 1. Find the exact value of sine A in simplest radical form. Okay, so again, I'm going to write SOHCAHTOA. SOHCAHTOA And I'm going to draw a right triangle. I'm emphasizing quadrant 1, so that's why I'm drawing my x and y axis like this. I draw my right triangle like so. Here's angle A. Cotangent, let's see, well, here's tangent. Tangent is opposite over adjacent, so that means cotangent is adjacent over opposite. If you want to put that in there to help you out. So adjacent has to be 5, so I'll put a 5 there. And then opposite has to be 2, so opposite is this guy, so 2. So there it is. They want me to find, what do they want me to find? Oh, by opposite, guys, it's like, where are you looking at, right? You're looking at opposite, so that's opposite. Now they want me to find sine A. So I need the hypotenuse. So here we go. That's just Pythagorean theorem. I'm just going to go straight out. I'm just going to say square root of 5 squared plus 2 squared because I'm looking for the longest side. And let's see, 5 squared is 25. 2 squared is 4. And 25 plus 4 squared is 29. And no, 29 does not bring down. If it was 27, it would, but 29 does not. All right, so now we got that, and it wants sine, so I'm going to write sine of A is equal to opposite. I'm looking at this one, opposite over hypotenuse. Opposite 2 over hypotenuse, square root of 29. Okay, do not write it in delta math like this because it says that it wants a rational denominator. So we're going to have to fix this, guys. I have a square root of 29 on the bottom, so I'm going to multiply by square root of 29 by square root of 29. Now I'm going to slow down because last year I remember asking one of you guys, like, why am I multiplying it by square root of 29 over square root of 29? Maybe it wasn't this question exactly, but something like that. And she told me, she was like, well, you always do it. So since you always do it, I'll just try to mimic what you're doing. And that's not the point. I'm not trying to make robots, guys. We're trying to use logic here. Square root of 29 over square root of 29, that is a 1. Anytime you multiply anything by 1, you get the same thing. Nothing changes. And the reason why we're multiplying it by the square root of 29 is because, here's a side note, don't write this down, just listen. Square root of happy face times square root of happy face is just happy face. The square roots go away. So that's why we do what we do. Now, in case you don't like happy faces, if you're going through a goth stage, like I am dark and I don't like happy faces. All right, fine, here's some triangles. So square root of triangle times square root of triangle is just triangle. So that's why we always just multiply by whatever we have in the denominator, guys. All right, so coming back, we're gonna have this, 2 square root of 29, and just like we just talked about right now down here, square root of 29 times square root of 29, that's just 29. Boom, there it is. I don't see anything reducing. That's what you would type in. All right, let's keep going. All right, cosecant A is square root of 97 over 4, and that angle A is in quadrant 1. Of course, they're all in quadrant 1 because I chose them all to be in quadrant 1. Find the exact value of secant A in simplest radical form. All right, let's do that. So here's my triangle. Again, they're all quadrant 1s, and here is angle A. And maybe you're getting tired of labeling the A all the time, so maybe we'll see if we can adjust that in the programming. And it says cosecant, so I'm going to write SOHCAHTOA to help me out. SOHCAHTOA. I know cosecant is a reciprocal. It's a reciprocal of which one? Yeah, you're right. Oh, the sine. Sine would have been opposite over hypotenuse, but since it's reciprocal, it's hypotenuse over opposite. So hypotenuse must be square root of 97. So there it is. And then opposite must be 4. There it is. All right. Here we go. I need, what do I need? It says that I want secant A, and secant's a reciprocal of cosine, so that means I need that guy. I need this length. So to do that, we're just going to go square root, and then square root of 97 squared minus 4 squared. All right, when we do that, square root of 97 squared is just 97. And then 4 squared is just 16. Are they being nice to us again? I think they are, guys. Let me make this not as long. Let's see, 97, 87, and then another 6, 81. Yep, they're being nice to us. So the square root of 81 is 9, so I put a 9 there, and I have everything I need now. Secant's the reciprocal of cosine. I underline the cosine, and I just do the opposite order. Hypotenuse, square root of 97, over adjacent, 9. There you go. All right, finally, we're on our last page. And relax, it's not even that extreme. This is from the ACT. I think everyone's now is going to get this one correct. Let's read it together, and then we'll set you guys loose for your local attendance, and then we'll give you the link. A ladder leans against a wall as shown if the height of the wall to the top of the ladder is 10 meters and the distance between the foot of the ladder to the wall is 7 meters. Which of the following equations could be used to find theta, the angle that ladder makes with the ground? Okay, answer this question on private chat for local attendance, just like yesterday. It's pretty straightforward, I think. Oops. It's pretty straightforward, I think, guys. If you didn't understand it, read it again. Let's give you 2 minutes. It's 9:31. I'll come back at 9:33. And let's get it done, guys. Let's go another 45 seconds, guys. It's okay if you get it wrong. All right, guys, let's start wrapping it up. If you haven't answered, let's get to it, please. All right, so they want me to write this as an equation, or it says, let's see, which of the following equations could be used to find theta? And I know that we haven't talked about taking the inverse of something to find an angle. That's another topic. But they give you theta here, and then with respect to theta, they give you that 10 and that 7. So I'm going to write SOHCAHTOA. And then let's see, with respect to theta, that is opposite, and the 7 is adjacent, because here's my right angle. So opposite over adjacent is tangent. So tangent of that angle equals 10 over 7. And there it is, so letter A. So the correct answer is letter A. So hopefully, it looks like almost all of you got it right. It's okay if you didn't, relax, we just need more experience. And I think that's the last question, guys. So yeah, let's all come back. Let me turn on the light here.